Good morning. We from the group Electrical Discharge Machine. Let me introduction our group. The member is Cahya Wardhana, number absent 4, and Atem Juach, Kelei Juach, number absent 5, and Bagus Prakoso, number absent 6. For introduction, the electrical discharge machining or EDM is a sophisticated manufacturing process that utilizes control electrical discharge to remove material from a workpiece, allowing for the creation of complex shape and intricate feature. This non-conventional machining technique is particularly effective for hard material that are challenging to machine using traditional method. For history, uh, 1770, the origin of EDM can be tracked back to the work of English scientist Joseph Priestley, who discovered the erosion effect of electrical discharge. Although he did not force its particular application, this finding laid the groundwork for future development in electrical machining. And then in 1940s, EDM as a machining process was developed during World War II by two Soviet researchers, Lorenzenko brothers, or Boris and Natalia. They refined the process by controlling electrical discharge to precisely remove material from a workpiece. This became known as the Lazarenko circuit. And then 1960s, the introduction of wire EDM technology revolutionized the file. This method used continuously feed wire as an electrode, allowing for intricate cut and shape that were previously difficult to achieve. The combination of wire EDM with computer numerical control or CNC further expand its application across various industries, especially in aerospace and medical manufacturing. And then for the component is power supply unit, the generate high voltage plus that create the electrical discharge between the electrode and the workpiece, control the frequency, amplitude, and duration of the pulse. And then the electric fluid, typically hydrocarbon oil or deionized water, is used to insulate the electric electrode and conduct the heat generated by electrical discharge. It also helps to flush away the erode material. And then electrode or tool. The electrode made of conductive material like graphite, copper, or brass. It's shaped to match the desired shape of the machine part. It is connected to the one terminal of the power supply. And then workpiece. The conductive material to be machined, it is connected to the other terminal of the power supply. And then machine table provides a rigid and stable perform for the EDM process. Process of power supply, electric fluid tank, and other component. And then control system. Control system the entire EDM process, including the power supply, electrode feed rate, and the electric fluid flow. It may also include feature for automated part programming and monitoring. And then cooling and filtration system. Uh, the electrical discharge without proper cooling, this head and lead on thermal distortion of the workpiece and electrode, compromising machining accuracy and surface quality. And then next,
So I'm going to explain about how the electric discharge machining, how how can it work, the work principle. So we can see Here, first is placement of electrodes and workpiece. Second, spark gap creation. Third, erosion process. And fourth is flushing. And we can go to the next slide. So in this picture, this is just showing the importance of dielectric fluid. And the dielectric fluid is are I'm going to explain more about the dielectric fluid in the next slides. Okay, so we can go to the next slides. So this is the function of dielectric fluid. So dielectric fluid acts as an insulting medium and cools the spark region and helps in keeping the tool and workpiece cool, carries away the eroded metal and particles along with it, uh, maintain constant resistance across the gap, remains electrically non-conductive until the required breakdown voltage is reached, and then breaks down electrically in the shortest possible time once the breakdown voltage is reached. We can go to the next slide. So this is just showing how the EDM machining is going to be. So you can see the tool there, the electrode. The shape of the tool is going to affect the machining process. Like what the shape of the tool is, what the result is going to be. For example, if the electrode is on a circular shape, so the result is going to be like cylindrical. We're going to discuss more on the next slides. So the working principle of EDM machining is uh, it is based on workpiece metal erosion with the application or spark discharge between the tool and the workpiece. We can go to the next slide. So here we can see when two current carrying conductors, there is a anode and cathode, are brought in close proximity, an electric arc is formed. The electric arc formed between the two conductors due to which at the point of contact a small amount of metal is eroded, leaving small cracks. Uh, this spark is mentioned on the red light, generates intense heat, causing the metal in this zone of spark and melt and evaporate when both the electrodes, that is anode and cathode, is made of the same material, the electrode, connected to the positive terminal erodes faster. Therefore, the workpiece is generally connected to the positive terminal. Go to the next slide. Yeah, so we can see the tool is up there with the blue color on top of the workpiece. So generally, a small gap of 0.005 millimeter or 0.05 millimeter is maintained between the tool and the workpiece. The spark occurs when the tool and workpiece are the closest. To increase the effectiveness of the process, the tool and the workpiece are immersed in the dielectric fluids such as hydrocarbon and mineral oils. Well, we can go to the next slide. So this is the construction of electrical discharge machining. So first we can see there is a DC pulse generator on the bottom left. So the function is to convert the AC power supply into a high pulse DC, responsible for generating a spark between the tool and the workpiece. So you can see the plus terminal is connected to the workpiece and the negative terminal is connected to the servo motor. So next is servo motor. The function is to control the feed of the tool, and then under the servo motor there is a spark generator. Spark generator supplies sufficient voltage for spark generation and maintains its discharge. And then there's a dielectric fluid. The dielectric fluid is shown as red color. Uh, the dielectric fluid is generally supplied in the form of a jet at the gap between the tool and the workpiece. The ionized water, silicon, oil, glycols, and etc. are generally used as the dielectric fluids. So we can go to the next slides. So this I will explain about the working process. So the tool should be the replica of the shape, as I mentioned before, to be generated on the workpiece. The tool is connected to the negative terminal of the power supply when the supply is turned on, DC supply. When the power supply is turned on, the DC pulse generator supplies a voltage pulse between 40 volts to 3000 volts. So the workpiece is connected to the positive terminal and the gap between the tool and the workpiece is filled with dielectric fluid. When the high voltage power is supplied to the tool, this causes particles in the electric fluid to concentrate. That is, the fluid gets ionized, forming a path for the current flow from the tool into the workpiece. This intense arc generated at the tool in the workpiece causes the workpiece material to vaporize. In this process, a small amount of tool material is also eroded. Once the spark is interrupted, the heat is removed by the dielectric fluid and carries the eroded metal particles, and the movement of the tool is controlled by the servo motor mechanism, which maintain the gap between the tool and the workpiece. We can go to the next slide.
All right, I'm going to take off from where my friend stopped about the type of EDM, the electrical discharge machining. First, we have on the screen here, we have 4 types: the singer, the wire, the EDM milling, and the hole. But first, let me give you a little bit of an understanding about them. So about the singer, when you see the word sing, is like something is put under a fluid, which is the dielectric fluid for this case. So the word sing simply means that the material being machined is submerged under the dielectric fluids. So it simply means that the electrodes is submerged in dielectric fluids, which is then used for removing the eroded metal. So for this case, sometimes the singer is sometimes called the die singing. Like we have to sing the die. Then the electrode is submerged under dielectric fluids for the material to be removed. And the material is obviously removed by electrical discharge, like the eroded kind of metal being discharged out. So going to the next one, which is the wire. When you see the wire, is what comes to your mind is something thin. So the wire utilizes the thin wires, the continuous thin wires. Usually they are made of brass, the brass metal. So these thin wires, they must be conductors actually, because for this case, we use the conductivity here. So the thin wires are then used to cut, or the thin wire cutting, they are used for cutting the material being machined. So these thin wires, they're used for cutting the intricate, the complicated one, the complicated kind of cutting, because for this kind of machining is actually precise. So they are used for cutting the intricate profile or the contours through the material. So you can use them for cutting 3D, 2D, something of that kind. So, but the term wired ADM simply mean we are using the thin wires for cutting. So when we go to the milling, so the milling ADM, so it is a milling shape, milling kind, maybe let me term it like it can be termed as a milling like operation. When we see in milling, the normal milling we do in the normal kind of machining. So milling, we simply mean that the material is being what? The material, the workpiece is the one rotating. So it simply means that electrode for this case is the one rotating like for the milling operation. So that is simple understanding about it. It's like the milling, the real milling operation we always do. So that is the case. For the hole is the simple. These are a specialized tool like used in creating small hole, the precise hole in the materials. So that's simply what we can say about the hole drilling, ADM. So it's used for creating the precise hole, which are too small for other kind of operation to be done. So that's what I can say about the types of ADM. So we go to the next slide. Yeah, for this slide is the important processes, variables in ADM. So these parameters, they're the one which facilitate the ADM to take place. Like we have to have the electrical apparatus. We need the electricity for this case, like the electric pitch, the currents, the on-time machining, the off-time machining. We need to consider all those. We go to the next one is the gap. The gap need to be considered. It's simply explained here that too close distance can cause short circuit, while too far distance can reduce the cutting efficiency. So when the limit is as put before that we have to put the certain clearance. So that clearance should not be too far, but should not be too close again. So, but it's maximum at least there. You can read it anywhere again. So the precise gap. So the second one is the type of the electrodes. The electrode material is considered, and the shape of the electrodes must be considered. To go fast, we have to consider the dielectric fluids, the type of dielectric fluids, the rate of flow of that fluids, then the filtration of that fluids. If that fluid have some components like a compound containing so many kind of different components, then the filtration need to be considered. Like, is it not containing some grease, like some foreign bodies? So to make it effective. So the feed also, the feed rate must be also considered. It is simply explained here that the feed rate affect the cutting rates and the surface finish. So the too high speed can cause rough surface, while the too low one can delay the cutting time. Obviously, when the cutting speed is too high, then the surface is not well off, rough surface. When we lower it again, then we are delaying the cutting time. So it should be maximum, at least the recommended one. So the workpiece condition, like the workpiece must be conductor for this case, because we are using the law of conductivity here to machine the object. So it must be a conductor. That's why we say conductivity. Then the hardness of that material is also considered, because this kind of machining, it can cut the strongest metals or the strongest materials. So that's why we consider the hardness of that material. So we go to the next slide. All right, then we come to advantages. So simply the ADM kind of machining, this conventional, the non-conventional kind of machining, it has the ability to cut the complex shapes. So take example, maybe you want to cut the operations for surgery, the tool for surgery in the medical side. Maybe they are too small for you to cut or to machine in other type of machining, but it is highly simple here. Like you have to cut the intricate kind of shapes, the complicated shapes. So you can cut them using ADM. So the second one that I can talk about is it has higher accuracy. The accuracy is too high. So it's highly precise because we are using the fluids. So when the fluid machine it slowly. So, and when you want to, like, it cannot damage your tool. Like when you see like the limit is reached, then you have to remove it. And that's all. It has high accuracy. Then the processing hardness, processing of hard materials. I said before about this. So it can be used for processing the toughest metals, the hard metals, because it uses the law of electrolytes actually. So the material must be eroded. though it is hard, then it must be eroded because that material is made of particles. But those particles are eroded slowly. So even though the material is too hard, then it can still be processed using ADM. So it is a non-contact process. So what we mean here is you cannot touch it. So you set up everything, then it will operate. Like you don't turn the workpiece, you don't do that, like the contact process. You don't have that high contact process with the machining process. It is flexibility in various machining, various materials. So it can be used for cutting any. It's not restricted to certain kind of metals. You can use it for cutting any. So it has smooth surface finish. Yeah, we said here clearly, like when you know the limit already, the speed of cut, the limits, then you get very smooth surface finish. So it has good surface finish, ability to create small and deep sole. Yes, as I said, I explained like in the first one, like when you're cutting complex shapes. So maybe you have some complex shapes in the jet engine. So those complex shapes or some holes, intricate holes, maybe for cooling the engine, the jet engine. So you can cut them. You can cut those small holes using ADM, but in other kind of machining, you cannot do it. So it has ability to create small and the deep hole. Reduction in vibration and stress. So it has that kind of, it has no vibration, actually, no vibration. So there's no stress being applied. So it just operates normally, cannot vibrate because we have only the chemical process. It is a chemical process. So it cannot vibrate. It uses the electricity and the whatever, and the process occurs there. So that's all what I can say about advantages. So we can go to the next slide. All right, disadvantages. So about disadvantages here, we can say the high operation cost is expensive. So the cost, like the starting cost, the cost associated with the electrolytes manufacturing, high energy consumption can increase the operation, the operation cost is very expensive, we can say about that. Difficulties in reproducing the shapes angles. Producing the shapes angles on the workpiece can be challenging due to the electrode weight. Like, you know, the workpiece is actually eroding, and the metal you are machining is also eroding. So the chemical reaction occurring there, the interaction between the electrons. So it can create that kind of difficulty in producing the sharp angles. Like, not the angles cannot be too sharp, like that sharp angle. So when the angle is having some kind of sharp shapes, then it cannot be actually precise, deeply precise. So, but it's actually precise actually, but not that sharp angle cannot be produced at the right point you need it. So the material limitation, the ADM can only be used in processing conductors. Yes, this is where the material limitation, it cannot be used for plastics and other materials. You cannot use it there. So it has to be a conductor, because we need the conductivity to take place, the cathode and the anodes to react. So that's some kind of disadvantage, because it cannot be used for plastics, woods, and all other things. Other materials like ceramics, you cannot use it there. So it can be used only for conductors. That's one disadvantage. And there is high power consumption. The ADM machine requires significant power consumption, which can process the issues regarding the energy efficiency. Yes, the machine has a lot of power consumption, because simply here, the power efficiency cannot be precise. Like when the power is consumed high, then it will lead to the efficiency of the power is not effective. So we go ahead. That's what I can say about disadvantages. Next slide. All right. So let's come to the applications of ADM. So when we see on the screen here, we have in the aerospace field, in the medical field, in automotives, in jewelry manufacturing, custom parts production, the tools, and the die making. I already explained some parts here, so I will go through little, and I think I explained a little about it when I was talking in the giving examples. So in the previous talk. So simply, let me go ahead here with the aerospace. In the aerospace, we can say that the ADM manufacturing is used in machining the toughest materials I said before, the strong materials like titanium in the jet engine. So you can use the ADM for manufacturing, or some complex part in the engine, in the jet engine, or in other kind of engine. The complex part can be machined using the ADM in automotives. That's what I can say about automotives. So we go to in the medical field. I said about the surgery before, the surgery tools. Those tools, they can be machined using ADM because they need high precision. The precision should be really very strict. So that's what I can say about manufacturing or the machining of the medical surgical kind of tools. So they can be machined using ADM. In automotives, in automotive industry, I can say that ADM is used in manufacturing the complex part in the engine, like the fuel injectors, the molds, in the plastic the plastic molds actually. So those are need precise kind of machining. So you use ADM. So the fuel injectors, so you can use ADM for manufacturing them. So next is about the die. So you use them for making the dies. So for the dies, like some dies, when you want to cut the die, then you can use the ADM for manufacturing it. In the jewelry, like you need to cut some complex shapes, the intricate shape in making your jewelries or your necklaces. So you can use the ADM for manufacturing those because they need precision, the high precision. In the custom part production, so I can say like in custom part production, we can use the ADM for manufacturing or prototyping the complex geometries in the custom part productions. So that's what I can say about the application. Like we can use it for the machining of ADM. So in various field, like all these field, that's what a little example that I can give you about them. So I think it's clear. We go to the next slide. All right. This brings us to the end of the ADM machining. So I hope the electrical discharge machining, we can generally say that is a kind of non-conventional machining process, which is actually very nice. So high precision, there is high precision, and we can get a lot of advantages more than other kind of conventional machining, like the normal machining. So this non-conventional machining is actually very productive in the manufacturing industries. So, and we can say like it's always when we get something that can manufacture complex shapes, like maybe in the normal conventional machining, you cannot use the normal conventional machining in manufacturing in the intricate shapes, like the most complex shapes. But for the ADM, it's simply okay. That's why the scientists before come up in 1940s and invent a machine. And it is actually very productive in the manufacturing world now, currently. So we can say that the ADM kind of machining, the electrical discharge machining, is actually very good non-conventional machining process. Which is productive in the manufacturing, in the machining technology, kind of machining technology. So thank you all, and hope you enjoyed it. And we still remain as your group So about the machining in advanced machining class. So this a little explanation we can give you, and thank you all, and I can say bye for now. All right, bye.
No. Mantap.